Hey, what's up guys, my name is Cherno and welcome to the next episode of the Serialization mini-series. So, last time we took a look at some basic stuff such as how binary works and how bit shifting and how all of the bitwise operators that we have work. In fact, here's a little table for you guys. And if you missed that video, there'll be like an annotation on the screen right now that'll take you guys to it. Because it's very important that you watch that video so that you understand how this video works. Because today we're going to be covering some of the basic things that we'll actually be using in order to achieve our serialization, okay? So we're actually going to start writing our library today. So we had this little binary kind of project. I'm just going to close that for now, and I'm going to make a new Java project. In fact, binary will probably remain as our kind of test project, but I'll call this one just serialization. That's pretty boring, isn't it? We'll call it RainCloud serialization because RainCloud, as I discussed, is going to be the game programming networking API. So RainCloud serialization, just like that. Cool. Binary is going to, I'm actually going to keep this project open. It's going to be our test. So the way that this is going to work is that I'm going to this is going to be purely an API. So we'll go com.cherno.raincloud or something like that. Serialization. And then we'll have like a serialization writer, which is what we're actually going to do today. We're going to work on the serialization writer. So this is, I'll explain what this is more or less in a minute here, but we're just making a new class in the source directory here. And there we go, serialization writer, right? And then what's going to happen is this is actually going to, so if we had something like a few methods here, which we will in a minute, such as public static, oh, a new Java update, cool, not now though. Public static int or public static void test, like we just had a method here. What we're going to do is click on this binary project, which is going to be our like test bench sandbox kind of deal. If you go to Java build path and then projects, you can actually add projects in your workspace to this project, and that's kind of the same thing as you would do in Visual Studio when you add references to other projects. Basically, that lets us still keep these guys separate, because this shouldn't have like any kind of main method or anything, because it's just a pure library. We don't have to keep re-exporting it as like a jar file or something like that, or have our test code inside this project. We can kind of take it out here. Now for this case, again, you might argue that's probably not that necessary, but remember, like there's no reason not to do it. In something like game programming, we will be having RainCloud as an actual separate library in the same workspace, so we'll do something like that. But anyway, there we have it. So now you can see if I were to do serialization writer, it would work. Test, for example, and that would work fine, even though that this is, it's in a different project. Okay, cool. So anyway, without further ado, let's get into this stuff. So it's a pretty long namespace, by the way, but anyway, let's get into this stuff. So this video, we're going to talk about starting our serialization writer. So what is our serialization writer? Well, this class is essentially responsible for interacting with pretty much the lowest level of operations, okay? So what this is going to do is it's going to ideally actually write our format, all right? Hence the name writer. So to kind of give you guys a more higher level overview, we give this serialization writer a bunch of bytes or a bunch of values. Usually it'll be like maybe a string or an integer or something like that, and it will actually write it into a byte array for us, okay? It might not be responsible for the actual input-output for files or network streams. It shouldn't do that stuff, but it's just going to basically write out our data into a massive byte array, and that's kind of the idea. All right, and it'll probably also carry bits of the file format with it as well. So let's begin writing this thing. So one of the first things I want to start off with is just a few basic constants that will define certain kind of determined aspects of our file format. So for example, we'll have a public static final, a byte array called I don't really want to call this header, but we'll call it header, right? And this will be a 2-byte array, which essentially, if we go back to our format here for a minute, you will see that I actually said that the first thing we see here is the 2 characters RC, okay, RainCloud. So to do that, easy way to do that is just to type in RC as a string and then hit the dot and then get bytes, all right? Simple as that. This will of course be a string, so this is the same thing as doing something like that. I don't know why you would do that, but you can do that. And yeah, wapoo. Okay, sneeze right there. Anyway, so we've got this RC here that we will extract the bytes from, and this should basically have 2 bytes for us, R and C. Okay, cool. So that's pretty simple. We'll also have, I think we decided to have something like a short, so 2-byte version here. So we'll have something like, we can just have this as a short, and I'll call it version. And for now, we'll just rock with something like 1. It doesn't really matter. This is a short as well, so it's actually this big. You'll probably see me write values as they appear in hexadecimal. So in other words, I'll take up the entire length of a short. So instead of writing that or that, which of course would be the same thing, I would write that just because when I'm reading this, this would make more sense because this is what it's actually going to look like. Okay. Another thing that I feel is important, but we'll probably get to this more when we actually have a product to look at, right? So once we actually start writing out the bytes and I can bring them up in like a hex editor and show you guys, is endianness. Okay. So this is what's called Bigendian. The reason it's called that, and endianness refers to the order of bytes. So what I mean by that is, you can basically, if you have 2 bytes to represent, like we do here, we've got, let's see, we've got 0 and we've got 1, right? There you go. There are 2 layouts in memory that we could use for this. We could either use little endian, which would mean that essentially the most significant bytes contain the beginning of our stream. Okay, so that would look like this. So essentially, memory-wise, it would look like that, which is a bit weird, yes. Personally, I don't like that. Or Bigendian, which is kind of the other way around. All right. So usually when you're looking at memory, you'll be looking at Bigendian. All right. And it's just a bit easier for us to deal with it like that. And it kind of makes more sense to me because if you're dealing with decimal as well, you wouldn't have something like, if you were writing something like 5 and you were using a bunch of zeros, you would typically do something like this and not that. That would look a bit weird. Okay. So since we kind of read this byte from left to right, I feel like it's probably good to read the whole thing left to right. A lot of people prefer little endian, but I don't understand why, honestly. Endianness is a very confusing topic, by the way. You'll always confuse the two. But for all intents and purposes right now, we'll be writing this in Bigendian. I don't even think you need to know that, okay? Like, I don't think there'll be a point at which we're like, oh my goodness, we need to convert from one endianness to another, because I just don't think that will happen, especially because we're dealing with a single platform here. We're not going to be certainly dealing with stuff like console CPUs or anything that might function in a different way and require the memory to be stored differently. So that should be totally fine, since we are developing for PC. Okay, cool. That's probably going to be about it for now. In fact, if I just look over here, so we've got flags. Yeah, we might as well implement stuff like flags. And then we'll move on to the name stuff. That name stuff won't really happen. So flags is, again, something that I don't actually want to write here. But typically we would have something like a byte called flags. The reason I want to write here is because it's not going to be concretely defined. I'm not going to just write it like that straight away, because this will actually depend on settings that we set. Whereas this stuff is not something that we should be able to set client side, because this has nothing to do with the data. The flags will have something to do with the actual data that we write out. For example, is it compressed? Is it part of a series? All that kind of stuff, right? But that's stuff that we set based on the data that we write. Whereas version and header are kind of concrete things that really should never be changed. So version really only should get changed once we actually increment a version, okay? In fact, I might change the version to be something like that, which I would kind of treat that like 1 byte for the major version, 1 byte for the minor version. So this is like 1.0. And just stick with that until we need to make minor revisions or major revisions or something like that. Okay, cool. So there we go. So let's talk about how we can write bytes out, and how we will be writing bytes out, in fact. So the way that this is going to work is actually really simple. We're going to have methods such as, they're going to all return integers. We're going to have methods such as setBytes, okay, or WriteBytes. You could call this whatever you want. I'm just going to call it Yeah, we'll call it write. Why not? It is the serialization writer. We'll have a destination. All right. So this is the byte array as to which into which we're actually going to write these bytes into. We're going to have a pointer, which is an integer. Now this is essentially the index of this destination array where we want to start writing to, okay? And then finally we have a value. So let's, for example, say that we're going to be writing out 1 byte, okay? So what this would look like is pretty simple. We would access the pointer index inside the destination array, okay? We would increment it after we're done. So yeah, we'll write it like that for now. And we would set, of course, it equal to value. So this is basically the same thing as writing that. I'm just kind of saving a line. And then finally, of course, we need to return pointer. The reason we're incrementing the pointer is because we're saying we've written bytes, and this is now the new pointer into that array, into where we're kind of up to, right? And this will make sense when I show you the usage in a minute. But that's kind of the idea, okay? So of course, instead of taking up an extra line here, we can just do something like pointer plus plus. This will write so if pointer was 0 when we fed it in, this will write the value to destination at index 0, then change pointer to 1, and then return pointer. So you could also write this as that, for example, because that is a pre-increment rather than a post-increment, which is what we had over here, okay? Anyway, we'll deal with something like this because this will make more sense once we add other things like shorts. So writing out a byte is very simple, okay? If we take a look at what this might look like in our main thing, one thing I'm going to do quickly is I'm actually going to import static the Cherno serialization writer dot asterisk here. All right, just so that we don't have to keep writing serialization writer dot WriteBytes, we can just write WriteBytes, as you can see. So if we had a byte array called data and we set it equal to, let's just say we want to deal with 16 bytes for now, and then we had a byte, I don't know, let's just say we wanted to write out this header, which we'll actually deal with because we don't have that yet. But let's just say we had a byte number, and I'll set it equal to like 10 or something, right? We wanted to write that out. We simply call WriteBytes. The destination would be data. The pointer in this case would be 0, and the value would be number. Okay, done. And that will actually set the first index, of course, of data to be that number, which is 10. Now, the reason the pointer exists is for this. We can set this equal to pointer, and then what we can do is actually just keep writing that number or something like that. So I can keep doing this, and what will happen is if we were actually to look at the byte array, so we might make a method here called static void print PrintBytes, all right, and it will take in a byte array. Whoops. So data. It would take in a byte array, and it would essentially, I think what we'll do for now is we'll just go through every index, every byte in there, and we'll just probably print it as a system.out.printf. We'll print it as a hexadecimal digit here. In fact, yeah, we'll write a decent thing here. We'll say that we'll just print it with a space at this point, and that should be enough for now because I don't think we've got a massive situation going on. But if we do something like this and we write it out, so PrintBytes data, all right. Oh, sorry. Make sure you feed pointer into each of these, obviously, because otherwise it's not going to do anything. So if we run that, I'm going to get a crash apparently. Illegal format conversion exception. Well, this is the first thing I've ever seen. Oh, right, of course. We need data I, okay? Otherwise, we're writing that whole array. Okay, there you go. So this looks pretty terrible. Let's write like 0x out the front or something. Okay, there we go. So this looks a bit better. So you can see how our bytes work right now. So A, of course, is 10. And then you can see that what it's done is it's written 10 a bunch of times. So we've decided to write it 1, 2, 3, 4, 5, 6 times. So you can see there are 6 A's over here. And then whatever we write to the next one, for example, write the number, let's just say 8, which will just be 8 in hexadecimal. Might need to cast that to a byte. You'll see that it sets 8 over here. Okay, so we've got a pretty automated way where we can just keep writing bytes in a sequence. Okay, and that's very important because, as you can imagine, we want it to look nice. Okay, instead of having to kind of maintain an index every time, we can just set a pointer and it will do it automatically. Now in this case, it's actually not that difficult. We could have easily rewritten this as something like data. We could have made an int pointer over here equal to something like 0 as it was before. And then we could have done something like pointer plus plus equals number, and then we could have just done that. And yes, that is, in this case, that might actually look nicer than what we had, okay? The problem arises when we want to write stuff that aren't simple bytes. So for example, if we wanted to write a short out, so short value, okay, we come to a problem because a short takes up 2 bytes, as you know. So how do we write 2 bytes into this? Well, obviously it's going to take up two indices in this destination array. That's the first thing. Now, from what you learned last episode, we know that we have the ability to extract certain bytes out of integers, for example, we looked at last time, but obviously any data type really. So what we need to do here is we need to simply extract 2 bytes out of here. So a short, of course, in memory is going to look like something, again, if we had like just the number 1, it would look like something, like this, right? So it would take up 2 bytes, and it would really just look like that, okay? So, that being said, we need to extract that first bit and write it out first, okay? So we're going Bigendian, so we're writing that bit out first, and then we're writing out the little endian, I guess, part, okay? Not endian, but just little part, okay? We're going to write that second thing up second. So we need to extract this. Now, via some bit masking and bit shifting, that is obviously going to be a piece of cake. So what we'll do here is we will say that the value, what we'll do is we will shift the value by 8. So this is actually kind of the reverse of what we did in the yesterday's thing, but it'll work the same way. So we can either shift the value this way. Let me just quickly cast that to a byte as well. There we go. Okay, so we could either do this, or a different way of writing the exact same statement would be like this. Let me just grab that whole chunk. And I'm not sure why you would do it that way. I think that that's a bit messy, because if we did choose to do it this way, if that didn't exist, then the next chunk would kind of be that, and this kind of starts looking weird where you have different lengths for this. So it's going to do the same thing really. I just think that this one looks nice, that's why I'm doing it. So then obviously the second one is just going to really be value and ff, but just to kind of make it look nice and align good, I'm just going to shift it by 0 places, which is going to do absolutely nothing, right? But it kind of looks nice. Cool, there we go. So now you can see we've incremented pointer twice, okay? And we've written out a short, which is pretty cool. But if we didn't have that, that would look a bit different over here. So if we had something like a short number, and we wanted to do this, first of all, we'd need this weird bit masking, but also we'd need to increment pointer by 2. And then this just starts looking very weird, okay? So that's why this whole technique is really, really good. Cool. So to make that work now, we just need to do something like WriteBytes. Destination will be data, pointer will be 0 in this case, value will be number. All right, and then I can just write that same 10 thing out a bunch of times, replacing pointer over here. Okay, and if I were to print the bytes, are we going to have enough space for that? Yes, we should. Then it's going to look something like this. So you can see we have the 0 and then A, then 0 and A, and 0 and A, etc. All right, so let's look at something above a value that we could store in 1 byte. So for example, let's just try and do the value 10,000. I've opened my programmer calculator here, which is just the normal calculator set to the programmer mode, which you can do by clicking on programmer here, or Alt-3. So I've punched in the value 10,000, and you can see that in hex that looks like 2710. All right, cool. So this is the value that I'm expecting to see. Let's punch that in. So we'll go 10,000. All right, and if we run this and we print it, you can see we see 2710. All right, and you can see kind of how that works. All right, so it's pretty simple. It works really well, I think. And this is kind of the most efficient way that I've discovered so far in doing this, okay? Because it seems to just work well and not take up too much code and look really clean as far as this goes. All right, I'm going to do one more today. We're going to cover more stuff next time, but we're just going to do the same thing here for an integer. Okay, and you can probably guess what this is, and we might as well do it for the long as well. But this is just going to be more of the same, except we'll have shifting by 16 and by 24 over here. And then for a long, that's going to be a big one. Long, of course, takes up 8 bytes. So it's going to just keep going up, really, by increments of 8. So 32, 40, and 48. No, that's wrong, because I missed one. 56 should be our last one. Okay, there you go. So that would be our long. And that's it. So if I, again, decide to print this as an integer and we do the same 10,000 or something like that, it's going to, we actually had just enough space there, by the way. 16, 4 times 4, of course, is 16. But 4 being the size of an integer and 4 being the amount of times we wrote it. But there you go. You can see that the first, of course, 2 bytes here are going to be 0. And then we're going to have that 2710 that we did for the short. So it just really takes up more space. We could have written this out as a short, but there we go. That's an example there. Cool. There we go. And a long, of course, will kind of look the same. I'll print out 2 longs because I can't do any more than that. We're really just going to get more zeros in this case. Okay, a lot of zeros here. But you can see that we could print something like along the max value, and there we go. Okay. Now it doesn't go all the way to FF because it still has negative values as well, which is why that's stored like that. So something like min value would be 0 with 8 0, meaning that it is negative. Anyway, we're not going to deal with how this actually works, but you can see that we've written, we've got the ability now to write a bunch of bytes to a destination array. Cool. The other important thing that we'll probably just talk more about this next time, but we'll deal with doubles and floats next time, which are going to be a bit different. And we'll also talk about why I've chosen this method and not stuff like byte buffer. And we'll probably might compare some performance characteristics of different ways you can write bytes. But this is, as far as I know, this is the fastest way to do it. But having said that, I've done like 0 testing. This is just kind of my assumption. All right, anyway, I hope you guys enjoyed this video. If you did, please hit the like button. If you really liked my videos and would like to see more, then you can support me on patreon.com/the Cherno. If you donate a certain amount per month, you get access to pretty cool features such as the entire source code for game programming via the private GitHub repository. I'll probably start adding more private GitHub repositories in the future as well with other projects such as 3D game programming. So stay tuned for that because I've got some news coming out pretty soon about that, which is pretty exciting. And if you like talking to people about programming and game development, then you're definitely going to want to join up on slack.thecherno.com. So this is basically like a team real-time messaging platform in which you can talk with all the different people in the Cherno community as well as me. I'm very frequently on there. So anyway, if you guys enjoyed this video, hit the like button, and next time we should have some pretty exciting times continuing with this serialization stuff. Goodbye.